Okay, in this video, we're going to talk about similarity that exists in right triangles, especially when you use something called the altitude and when you apply a concept called geometric means. Okay? Let's start with a couple definitions so we just are clear that we're all on the same page. Right triangles. Remember that right triangles form 90-degree angles, right? There is one angle in the triangle that is a 90-degree angle, and it's connoted by this particular little symbol right here, this little box in the corner, okay? They're also perpendicular. These lines are perpendicular to one another. A couple other definitions. Remember that in a right triangle, this long part here, the side that's opposite the 90-degree angle, is called a hypotenuse. The side at the bottom here, this little shorter side, that's called the short leg. And this longer side is called, strangely enough, the long leg. Okay? Now, the altitude is a line that is drawn from the 90-degree angle straight down, perpendicular to the hypotenuse, forming another 90-degree angle. Okay? Now, look what that does. It forms 1, 2, 3 right triangles. And all those right triangles are similar to one another. And remember what the word similar means. Similar means that all the ratios of the sides and the ratios of the angles actually are proportionate to each other. Okay? Let me label this a little bit more so we can start making some relationships and show you how that works. So we'll call that vertex A, B, C. Let's call that D. Okay. And let's see what else we can do here. Let's call the long leg of the big triangle, or the line segment AB, we'll call that little a. Let's call this line segment right here BC, or the short leg of the big triangle. Let's call that B. And let's call the hypotenuse of the big triangle little c, okay? And I'm just going to do that so that we can see that it's a length. Now, something that I forgot to mention about the altitude, it's also called the height. So let me just write that in there. It's also called the height of the large triangle. So let's just label that as h. All right? So small h. And then finally, remember that the altitude breaks the large triangle's hypotenuse into two smaller segments, right? So let's call this x. Let's call that y. So basically what we're saying is that small c is equal to the length of x plus the length of y, okay? That gives me that whole thing. Now, there's a lot we can do with all this information, right? We could find the lengths of different sides by using the Pythagorean theorem. Remember that? A squared plus b squared is equal to c squared. And that just means that the short leg and the long leg squared, each of them individually, is equal to the hypotenuse squared. All right, that's what that means. That, not the a, b, and the c necessarily, but that's what it means. So that's a couple of things we could do. But there's another way of doing it, and that's something called the geometric means. We can find these small letters by using the geometric means. And let me show you how that works. So we're going to draw a different triangle because it gets a little messy here. All right, so let's redo the triangle that we just drew. Okay. There we go. Here's the altitude coming straight down. And this also goes on that side too, by the way, just so to make clear, all right? We said that was A, big B, big C. We said that that line there was D. We said that this side was A, this side was small b, this side was small c. There we go. We said that this shorter part here was x. We said this one was y. And we called that one h. Okay. Now let's draw some relationships here. There's a lot of relationships that we can actually draw if these are indeed similar triangles, and they are. So one of the relationships that I want to point out in particular is this one. Let's say that the hypotenuse C of the big triangle is to its short leg B, all right? And the proportions for any of these smaller triangles would be the same. So let's lose this little triangle right here. So we know that the hypotenuse is to the short leg. So this hypotenuse would be B to its little short leg, which is Y. Okay, now why did I choose those? Because you might have noticed, if you remember what a geometric means is, it's when the same variable is in the numerator and the denominator in a proportion like this. All right? So that's called a geometric means. And we know that we can actually solve for a geometric means, right? By doing the cross multiplying. So let's do that. Cross products, I think it's called. So b times b gives me b squared. C times y is just cy. Now remember what you do with that. You have to take the square root of both sides for the geometric means, so we can do that as well. And we'll get the square root of b squared is equal to the square root of cy, and the final answer would be b is equal to the square root of cy. If we happen to know what some of those lengths were, we would be able to figure out what the length of b is, okay? Now, let me show you an actual problem where we would be using something like that, okay? So I'll show you what kind of problem that we could use here. Let's do this. Let's just move all that out of the way. And let's go ahead and rewrite a new problem. So here's our triangle again. Whoops, that's still put out of the... There we go. Okay. Let's do that. Let's draw our altitude. Let's say that the large length here, this hypotenuse, let's say that that's 20. Okay? Let's say that we don't know what this hypotenuse is, or this short leg for the large triangle is. And let's say that we know that this one here, this little short leg of this big triangle, or this little line segment, let's say we know that that is, I don't know, let's say 8. Now let's say 4. Let's say 4. And then let's just mark everything else the way we know it was. So we'll call that A, B, big C, small. Yeah, we got it all. And we wanted to find the length of B. Now again, we could do a Pythagorean theorem. We could say a squared plus b squared is equal to c squared, or 20 squared. But the problem is we're not going to be able to, we have two variables still. So that's not going to work. So how else can we figure out what b is equal to? We can use geometric means. Let me show you. So the hypotenuse, 20, is to the short leg b as this little hypotenuse, b, is to its short leg, 4. Okay, because it's similar triangles, right? And we know that that relationship works. So now let's go ahead and apply the geometric means. B times b is b squared, is equal to 4 times 20, which is 80. Let's take the square root of both sides, and you get b is equal to the square root of 80. Now, we know that the square root of 81 is 9, right? So we know that this is approximately 9, but normally you don't leave it like that, and you don't use decimals, really. Normally you leave those in radical form, so you're going to have to remember how to simplify radicals. So remember, you look for the largest perfect square in 80, perfect square factor, and I know that 4 is a perfect square, but 20 also has a perfect square, right? So it's 4 times 4, 16. That would be 16 times 5, right? That means it's 4 radical 5. And let's just mark that out. So now we know that the length b is 4 radical 5. Okay? Whoops, sorry about that. We know that the length b is 4 radical 5. And we can actually check that too, right? Because a squared plus b squared would equal c squared. So let's just try that. So a squared plus b squared, which we now know is 4 radical 5, is equal to 20 squared. Okay, now let's go ahead and start solving this. A squared plus 4 radical 5 squared would be 16 times 5, or 80. And that's going to be equal to 20 times 20, which is 400. Let's subtract. You get a squared is equal to 320. A then would be equal to the square root of 320. And then again, you have to do the exact same thing we did over here. Okay, you know what? I think I'm just going to leave that go. I'm going to let you decide whether that's correct or not. Okay. But anyway, that's how you find the different lengths. You can use either the Pythagorean theorem or the geometric means, and you use the most appropriate one when it's available. Okay, I hope that was helpful.